Alright guys, here we are for day 4, and I'm going to go over a few of the little things that I'm going to be changing on this motor. Basically the bottom line is, these Type R motors are they're practically bulletproof from the factory. I mean, a lot of the things that people end up doing to their GSRs or their B16s, whether it's the camshafts, the valves, rebalancing the crank, these things come from the factory just like that. So there's no need for me to change any of those things. That said, there's a few little things, and this is what we're going to be talking about. The main thing that causes horsepower drop, especially on naturally aspirated motors, is the fact that the faster you spin the motor, the higher the RPM, the more forces are exerted in the motor, and the block itself actually begins to sort of twist under all the fatigue. Now, in a perfect world, if there was no friction losses at higher RPMs, if you could keep spinning that motor faster and faster and faster, you would practically have unlimited horsepower. It's just, as RPMs increase, the fatigue increases, the clearance between the bearings and the journals and the rod itself, the crank itself, become tighter and tighter, and actually starts to sort of clamp down on those, lubrication surfaces. So the Type R motor, what it does to sort of counteract that, for instance, all of the bearings, whether for the top or the bottom of, say, the connecting rods, they actually tend to have the top part a different thickness than the bottom part. Honda sells them in 5 different sizes, from relatively large to relatively small. And when these were assembled from the factory, to get clearances super close, they would mix and match, have a medium thickness bearing on the bottom, but a thinner or a thicker one on the top, so the overall clearances were just that much closer. Just like the GSR blocks, these Type Rs also come with those lower crank girdles, again, for strength and to keep them from flexing. And the crankshaft is actually different. Honda crankshafts are known because they're, one of the relatively few 4-cylinder motors, especially when they first came out, that had such a fully balanced crankshaft. Well, the Type Rs really take that to a new step. If you compare them side by side, Type R crankshaft, every one of the counterweights is a full-size counterweight. And the reason for that is a 4-cylinder engine is really sort of a harmonically hard to balance motor from the get-go. It's not like a V6 or a V8 where you have enough firing events in different directions that the motor is more or less harmonically balanced. I mean, with a 4-cylinder, you're really trying to convert an up and down motion into a rotating motion, and that's just really, really hard. So the more harmonic variance and vibration you can cancel out, and the better you can control your clearances for your oil passages and your journals and your bearings, the more horsepower you have at higher RPM, and the motor itself can spin more freely. So here's what we're going to be doing. Crankshaft is set, I'm not going to worry about that. But what we are going to do is actually have a special kind of crank pulley. Honda crank pulleys normally are harmonically balanced. They have a rubber inner ring that helps dampen vibration. And since we're starting this motor off right, we're going to actually use a fluid damper pulley. Now, if you've seen these, they sell 2 kinds. They sell a race kind, but they also sell one that's for street. The race one is purely for race. It only has a pulley position for the alternator. It's actually an undersized pulley position. And then the entire other part of it is sort of a spring dampened counterweight. On the street series though, check this out. You get all of the original pulley mount locations that you'd have in your factory pulley, but you get the added protection of fluid damper sort of proprietary balancers. So here it is. So this is the Fluid Damper Street Series. As you can see, you've got your 3 positions for your regular pulleys, your power steering, air conditioning, and your alternator. The idea is, as this spins up, the pulley itself also helps to counteract those harmonic variations to the motor. And so now we have a very, very strong, counterweighted crankshaft would have all the journals and the bearings perfectly toleranced. You have that lower girdle in there. I mean, this is just going to help that much more. By putting one of these things on, you will actually see a difference on your higher RPM horsepower, where you would start getting those harmonic variances. And if anything, your torque curve itself will also be more of a smooth line. There'll be less jitter in it, all for the same reasons. So that's one thing we're replacing on this Type R motor. Second thing, we're going to be replacing, instead of using factory head bolts, we're using ARP head studs. They're sort of the industry standard on these things. The reason being, aside from the fact that ARP has become the de facto in high quality, exceptionally strong strength hardened steel products, the reason you want to go from head bolts to head studs, because the aluminum block is aluminum. It's a relatively soft metal, especially compared to your steel bolts. And as you tighten these bolts down, your factory bolts, it is possible to actually strip out the metal out of the block. Now, when you're tightening those bolts, the threads on the bolt itself are actually in effect sort of drilling into the motor. So if you keep going too tight, eventually those threads will pull out. With the studs, what happens is you tighten the studs in first, then you drop the head, and then you put down the fasteners on top. And instead of a twisting motion as they go down, you have a spacer washer and a nut on top. And the benefit is you get a smoother, more consistent force applied. So like I said, this is going to be into your block. You'll have a washer under here that is provided. And as you start to tighten these things down, instead of the entire bolt twisting and kind of working its way into that soft metal, it's just going to clamp down straight on top. This is particularly beneficial to people with high compression, naturally aspirated drag motors, or if you're running boost. I mean, if you're running these things, high compression, high boost, this is almost a must. And they are, the industry standard. They're very strong. You can't go wrong with them. So, ARP head studs to the factory Honda bolts. That's number 2. When we get to the clutch and the flywheel as well, just because we have to take off mine and we're going to be transferring it over, we'll be doing the same thing. We're going to be using ARPs on both for the pressure plate and for the flywheel. Again, they are the industry standard. They are stronger than the factory ones, and you get that reassurance. So, both for the pressure plates and for the flywheel, ARP products as well. Now, moving on, we're going to be using one of our in-house reusable thermal gaskets. This will provide heat insulation from the head into the manifold, keeping the manifold cool, especially when you're in stop and go traffic or you're just sitting there. This would increase your lower intake temperatures, lower coolant temperatures all the way around. I mean, it's very beneficial, and they are reusable. However, what people don't tell you about, because these things are obviously much thicker, especially if you're running an older motor with some older studs, you don't get as much thread engagement using the factory intake manifold studs. So, along with the thermal gasket, we're going to be using a set of inline 4s extended studs for the intake manifold. Now, these are kind of a unique design. You get an extra about 1/4 inch of engagement to counteract thicker intake manifold gasket. And the nice thing about the inline ones, on the outside of them, there's a small Allen key. So you'll be able to actually insert this into the cylinder head, use your Allen key to tighten them in, and of course if you have to remove them, same thing, it's easy removal. You don't need to do the 2-nut lock trick. So, in conjunction with our inline 4 thermal gasket, we're using inline 4 extended manifold studs, and the hardware supply for that. So, we've seen instances where people have just worn out studs, they don't provide enough engagement on their older ones. The weight of the manifold over time, especially if it's not supported by the bracket underneath, can start causing fatigue. You might see some crack marks on, lower quality intake manifolds. So it's a simple thing. If you're going to be getting in there to change the manifold, definitely consider this. It's a very cheap and a very, smart thing to do when you change your intake manifolds or your gaskets. Same thing with the throttle body. We're using inline 4-zone throttle body. Thermal gaskets, we sell these for, D series, B, H, F series. We have them from 60 mil, 65, 68, 70, and at least 72. So in this case, we're going to be using a 65 millimeter, and we're going to actually be doing a process to our throttle body to match it to this diameter. If you're using, very large throttle bodies, or you bored them out, and the space between the inside of the throttle body and the idle air control valve passage, it's really, really tight. That's often a place of failure for paper gaskets. These thicker gaskets will be able to hold that better, and it'll help reduce any people having problems with vacuum leaks or that kind of thing, idle problems. They have very large overboard diameter throttle bodies or intake manifolds. As for the throttle body, we'll just be using a Type R throttle body from a US motor. These are actually 2 millimeters oversized. The factory ones are 60 mil. And when you get your die calipers in for these guys, they measure out. There we go. Measure out to exactly 62 millimeters. That's the factory configuration, 2 mils over. What I'm going to be doing with this one is we're going to get this sent out to our machine shop, and we're going to actually bore and taper this throttle body up to about 65. And the thing is, here's an example. This is one of our in-house throttle bodies that we do this service to. We bore out the throttle body, and we actually provide a taper. So it starts at a larger diameter, tapers into the throttle plate, and then tapers out. And basically, it's the idea of a given amount of volume of fluid moving through a confined space. If you restrict that fluid has to go through that space at a higher speed. Anybody who's seen a garden hose, you put your thumb on it and you get higher pressure water. It's the same volume, higher pressure. This is the same thing for your throttle body. So it actually will improve your intake air velocity. So we can taper out factory throttle bodies up to about 68 millimeters. The usual procedure for this is you provide a core for us. Then we replace the throttle plate. We bore it out to the diameter that you want, and then we bring it back to you. And the turnaround time is very quick on these things. So this is an example of one we've already done. Again, the idea is it's a taper. You can see that in the close-up. And so we'll be using a factory throttle body, Type R throttle body, but bored out to that taper. So this is especially beneficial for people that want to keep that really sleeper look, or they have to comply to special emission standards. This can give you all the performance benefits of a large throttle body, but still keep you in the green when it comes to smog or, highway patrol pullovers, that kind of thing. So that's what we're going to be doing for that. The air conditioner bracket on all, US spec B16s or B18s is cast iron piece. The Japanese ones, they offered an aluminum bracket, and so that's what we got here. It sounds ridiculous, I know, but until you've taken off your aluminum, or until you've actually taken off your cast iron one and realize it's actually a pretty heavy piece, you kind of realize the benefit of this. This was used on the Japanese Type Rs. It's a soft piece of aluminum, and you're comparing the difference between about a 10-pound piece versus about 2-pound piece. So again, this is for the air conditioner bracket. That also ties into the motor mount down there. And so you still get the lightweightness, but if you need to use those lower torque mounts, you can use this piece and accommodate that to your needs as well. So that's also going on the engine. So the other question I always get with this is, why are you doing this? Why aren't you, going to change out the valve train or the pistons and this and that? And it really comes down to, a Type R motor is really, an amazingly well-built piece from the get-go. And for what my plans are for this vehicle, replacing the valve trains or anything, or the valve train, the cams, the gears, really isn't going to give me much of a benefit. The idea behind this is, let's get a brand new block from the dealer, get a brand new head from the dealer. We're going to be getting, brand new parts for all of the sensors, the hoses, the brackets. We're even going down to the individual bolts. Every single bolt, every single O-ring is all going to be coming out of a brand new sealed Honda bag. And we're basically going to be going down, part by part, through the service manual to build this engine. It's like take out motor, take out bracket, apply bracket to motor, take out Honda volt, blah blah blah, put it in, torque down to whatever spec it is. So it should be a really bulletproof idea, bulletproof motor. And the idea again is from throttle body all the way to the studs of the exhaust manifold. It's going to be bolt for bolt, gasket for gasket, a brand new engine. As far as why I'm not changing out the camshafts, the idea is this motor is going to be used for a supercharged project over the summer. And with a supercharged motor or a turbo motor, a lot of the performance upgrades you do for a naturally aspirated one, whether it's high compression, large duration camshafts, the philosophy for tuning a naturally aspirated motor is completely the opposite for forced induction. Having high compression means you got to have lower boost amounts, and that's not going to give you as much horsepower. Having large camshafts that have high duration will actually mean your cylinders won't be able to hold the boost that they're supposed to. It'll actually go directly into the intake and then right at the exhaust valve before they close. So there's nothing much we're going to need to be changing to this Type R motor to reach, what's in my mind going to be a very modest, but at the same time very high horsepower forced induction motor. So all the parts we're basically changing are just things that are more for the strength and the reliability of the part, and then it's just a matter of letting the Type R motor do what it does best. It's high revs, it breathes very well, the intake and exhaust ports have already been buffed and polished. You already have your proven valve train, you have your steel factory camshafts that are Type R spec. They're not shell cast iron, they're not billet aluminum, they're steel, they'll never die. The Type R intake manifold, it was the design that everyone based theirs off of in the late 90s, early 2000s, so it is again the gold standard. It could be argued that I could see some performance gains if I changed to a different style intake manifold, but just for the concept and the idea behind this motor, it probably wouldn't give me as big of a benefit. I'm not going for absolute maximum horsepower. It's more of the idea of, can this be done? Can we build, 12 years after these things have been discontinued, can we build a brand new, bolt for bolt, part for part, brand new B18C5? And if it's done right, and this is the kind of kicker, because we're using all brand new Honda parts, and because the head assembly and the block assembly actually comes completely sealed and assembled, by a Honda technician, they're also covered under the same, 3-year, 36,000 mile warranty that any part normally does. If you go to Honda and you buy a Honda water pump, even if you yourself install it, if the pump itself fails, the pump is covered under Honda's, Honda America's warranty. Maybe not the gasket because you're the one who put that on, but if the pump mechanically fails or the distributor fails internally, the part itself is covered. And since we're going to be doing this, we have our short block in there, our cylinder head, and the other emission slash gasket slash sensor should be coming in tomorrow. We'll start assembling that thing. Since they're all brand new parts, the entire motor itself will also be completely covered under a 36,000 mile 3-year warranty. So this would be pretty cool. Not very often you come across a brand new 12-year-old motor. So that's the idea. It's all Type R parts. It's just we're changing the little things to sort of improve the reliability, the better head studs, the thermal gaskets, intermanifold studs, slightly oversized throttle body, the fluid damper, crank damper, again for that higher harmonic vibration and dampening, and of course our lovely cast aluminum AC bracket. So that's the updates. If we get any new parts coming in tomorrow, which I hope, I'll go over that. And yeah, all said and done, we should be able to get this thing even, fully revved and fully smogged. It'll be really kind of cool. So, thanks for tuning in. We'll see you guys for part 5.